Hi guys, welcome to the screencast for tomorrow's lesson. So what we're looking at now is lung volume. So just a quick recap over what we've done in regards to the respiratory system. The main thing's been looking at over the past 3 to 4 lessons. First of all, we did the structure of the respiratory system. So we've done the nasal cavity, trachea, bronchi, bronchioles. Then we've got the alveoli. Then we've done the mechanics of breathing. So how do we actually get air from the outside atmosphere into our lungs? So the mechanics of breathing with regards to inspiration and expiration. From that, once we've got the actual air into our lungs, what happens then? So we have gaseous exchange, i.e. getting oxygen to the working muscles and removing carbon dioxide from the body and breathing it out into the atmosphere. So what now we need to look at are lung volumes. So what are the volumes we can actually take within our lungs when we either inspire or expire? So that's what the focus is going to be on. So for your corner notes, I want you to put these key terms down, please. So tidal volume, breathing frequency, minute ventilation, inspiratory reserve volume, expiratory reserve volume, and residual volume. Now, for minute ventilation, you're going to see it as pulmonary ventilation on this screencast, okay? It can also be termed minute ventilation, so that's something you're just going to have to be aware of. This is an exam question from past paper of last year. What you may actually get a question on with regards to the respiratory system and the volumes. First one, state the meaning of the term total lung volume. And then secondly, give the total lung volume, including units for an average healthy adult male. This is something we'll be going through in tomorrow's lesson. So first of all, tidal volume. What is tidal volume? It is the amount of air inspired or expired per breath, and our average is 500 ml at rest. So that's 0.5 litres, you may see it as. Now just think about tidal volume, the amount of air inspired or expired per breath. It's very similar to stroke volume, where we had stroke volume was the amount of blood ejected from the heart per beat. This is for lungs, and this is obviously talking about the amount of air either inspired or expired per breath. That's tidal volume. Breathing frequency, you may also see this as breathing rate in exam papers or just people discussing it and talking about it. So breathing frequency is the amount of times we inspire or expire per minute. So the average is 12 breaths per minute. It's not beats per minute here, it's breaths per minute, okay? So breathing frequency, the amount of times we inspire or expire per minute. And then finally, pulmonary ventilation or minute ventilation, as you may see it, is the volume of air inspired or expired per minute. Now this is very similar to cardiac output in the sense of you have an equation for this, and the equation for pulmonary ventilation is breathing rate or breathing frequency times tidal volume. So it's just these two figures times by each other give you pulmonary ventilation or minute ventilation, which is the volume of air inspired or expired per minute. For example, here we've got 12 breaths because we've got 12 breaths a minute. So breathing frequency, 12 breaths, times tidal volume, 0.5 litres, 500 ml, 0.5 litres. 6 litres is our pulmonary ventilation or our minute ventilation. And that is literally the answer to this last one here. Give the total lung volume, including units for an average healthy adult male. It is 6 litres per minute. We have to know it's litres per minute. That is the actual unit measurement we're looking at. Okay, so for the next notes we have inspiratory reserve volume. This is the volume able to be forcibly inspired during normal breathing. And the average at rest is 3 litres. Then we have the expiratory reserve volume, the volume able to be forcibly expired after a normal breath. Average at rest is 1.3 litres. Now this is pretty much tidal volume. Tidal volume is the amount of air we breathe in during inspiration or expiration. Well, this is very similar. Inspiratory reserve volume, it's the volume able to be forcibly inspired during normal breathing, and the same goes for expiratory reserve volume. Then we have residual volume. So this is the volume of air that remains in the lungs after forced maximum expiration. Average at rest is 1.2 litres, and this no change, it's just saying there's no change with regards to exercise. So here we go, here we have inspiratory reserve volume. i.e. how much we can forcibly breathe in. Expiratory reserve volume, how much we can forcibly breathe out of a normal breath. And then finally our reserve, or residual volume I should say, sorry, is here, and this is the volume of air that remains in the lungs after forced maximum expiration. So they're your Cornell notes for the lesson. Please guys, if you can get those down, I'll appreciate it, and I'll see you in tomorrow's lesson. Thank you.